So, shall I start the session?
Madam, am I audible?
Yes,
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 sir.
you are audible.
You are
Okay.
audible.
Okay. Thank you.
Good evening, everyone. On behalf of Organizing Committee of the Department of Computer Science and Engineering of MCKVIE, I, Momita Goswami, would like to welcome you all on our 10th session of the AICTE sponsored 6 days online ATAL faculty development program on quantum age intelligence organized by Department of Computer Science and Engineering of MCKV Institute of Engineering. Today, we are honored to have with us Dr. Samarjit Roy, who will deliver his lecture on AI in Edge Fog and Cloud Infrastructure. And it's my pleasure to introduce our eminent speaker. Dr. Samarjit Roy is currently working as a research scientist, School of Computing and IT at Eastern International University of Bicamex IDC Corporation, Ho Chi Minh City, Vietnam, and visiting scientist at CICC MMU, Malaysia. He had worked as an associate professor of CSE department at JIS Group, Kolkata, India. He has also served as a postdoctoral research scientist at the Rudar Boskovic Institute, Zagreb, Croatia, and honorary project professor at AU, Oxford, UK. Formerly, he served as an assistant professor, School of Computer Science, Engineering and Applications, and information scientist at the D.Y. Patil International University, Pune, Maharashtra. He was a UGC Senior Research Fellow in the Department of Computer Science and Engineering, Maulana Abul Kalam Azad University of Technology, West Bengal. He has received the PhD in Computer Science and Engineering on Intelligent Musical Pattern Recognition and Information Retrieval. He worked as an assistant professor and head in the Department of Computer Science and Engineering, Techno India, Ranchi, Jharkhand. He completed his MTech in Information Technology from Manipal Institute of Technology and BTech in Information Technology from Government College of Engineering and Leather Technology, Kolkata. His research area include musical pattern recognition, intelligent information retrieval, context-aware recommender system, speech audio signal processing, cloud, due edge fog computing, soft computing, machine deep representation learning, Internet of Music Things, crowd sensing, and data analytics. He has published more than 80 research articles, 4 books, 15 book chapters, etc. in numerous reputed international journals, conferences, and with other publication societies. He has achieved several international and national research recognition, such as the Young Scientist Award, Young Researchers Award, Scientist of the Year 2020 from Illinois, USA, Socrates Award from Academic Union, Oxford, UK, Honorary Professor Project, Oxford, and Doctoral Fellowship from University Grant Commission, Government of India in Engineering and Technology section. He has organized and participated in several national and international conferences, workshops, symposium, STTPs, and FDPs. He has been serving as the guest editor in the IEEE Transaction on Consumer Electronics. He is a life fellow of the Institution of Electronics and Telecommunication Engineers, India. Senior member of IEEE, ComSoc at 10, member of IEEE URSI in Drash, IEEE Due Computing Society, Subcomputing Research Society, and MTTF in. So without further delay, I now request Sir to kindly carry out the session now. Over to you,
Yes, madam.
sir. Please, sir.
Yes, thank you. Thank you very much, madam, for introducing me nicely in this platform. That session is of Resourceful Faculty Development Program, which is organized by the Department of Computer Science and Engineering of MCKVIE, one of the finest engineering colleges in our state. And I'm very privileged to be here with you all. So I would like to say good evening to everyone. So my respected professors, the faculty members, and the distinguished participants, along with the entire FDP organizing team. Hope you are all well and you are doing very good. So today, as Madam was introducing me in this endeavor, then I was thinking that I am not so explainable and responsible till date, right? So to deliver the potential in-depth black boxes of AI, cloud computing, the cyber physical systems, and so on. So what we are going to discuss with you today on the just a similar paradigm, and as well as you have to endure me for the next 60 to 90 minutes in this platform. So without the further delay, as Madam said, we are going to start here. So as you can see in the screen, first of all, is my screen visible to everyone? Can you please make me sure?
Yes, sir.
Okay, okay, fine. Thank you. So as you can see in the screen that the
Sir, would
presentation
you
title
please
was,
switch on your video once? We will just take a snapshot and after that you can switch off.
Madam, can we take this photograph after the session?
Yes, sir. No
Okay.
problem.
Okay, so let's discuss with all the participants and with the faculties, and after that we will take the snapshots. Okay. Okay. Thank you. So, okay. So the title for my presentation is the bridging of topic modeling and sustainable AI applications in cloud due edge fog. That is called, in summary, the CDEF environment. So as you can see that in my topic already we are going to discuss on the topic itself, right? So this is quite strange. These paradigms are quite similar to the explainable and the responsible AI, as I have already told you, along with the interpretable AI as well. So how we are going to depict this platform to extract the salient features, the latent features within the data, within the multimedia context, within the disruptive IoT information, within the time series data, the social media environments, like that, right? So here we can start with the domains of today's discussion. Let me make it. Okay. So the domains, at first we are going to discuss the topic modeling, what the topic modeling is, and then based on that topic modeling, we are going to discuss some of the theoretical concepts on the knowledge representation, the mathematical backgrounds of the topic modeling, the optimization mechanisms through the topic modeling we can depict, we can synthesize, along with the how the topic modeling can be integrated with the potential cyber physical systems and the cloud computing environments or the cloud computing continuum, such as the CDEF computing, as I have already told you in the title slide, right? And lastly, we will discuss some of the sustainable efforts towards the distributed AI, how the sustainable computing can be integrated to the cloud computing environments, right? Next, we are going to discuss some of the computational schemas on the. So some of the computational schemas which are already been developed till the day, and along with that, some of the future development, the future schemas which can be beneficial for the society, for the healthcare systems, for the human sentiments, internet of behaviors, internet of sounds, internet of multimedia context, like that. So we will discuss. Next, we will discuss the case studies, several case studies on the sustainable societies where the disruptive IoT and the conventional IoT, you can say, that meets the computational musicology. We will see, we will check, we will discuss some of the articles, some of the mechanisms, some of the result analysis, some performance metrics towards the paradigm that we have termed as the Internet of Musical Things. Next one is the multimedia information fusion, where all the professionalized and the personalized IoT fusion paradigms will be integrated. Next, we will discuss some of the future perspectives, the future case studies, where the AI, the topic modeling, as well as the CDF computing can be beneficial towards serving the societies, right? As well as some observations and some research trends, some research questions we will also going to discuss. So these are some motivations I have presented in a process flow. So we are going to start with the first point, that we can say the explosion of the disruptive IoT data, right? We are living in the society, in the world where the explosions of the IoT and the multimedia data informations are really occurred very frequently, right? So that's why we require some real-time intelligences for in case of the autonomous driving, in the context of the smart healthcares, in the context of the smart grid, smart transportation, right? So to provide the services towards the customers, to the end users, to the societal people, towards the social human beings, right? So next, we can say that the paradigm should be sustainable, right? This paradigm should be sustainable, and we cannot afford much energy. We cannot dissipate much power, right? So we have to minimize the data transmission and the service delay towards the end users, towards the customers. So that's why we have to form some real-time AI strategies. So that's why basically the topic modeling has been come into picture for extracting the insights, the features from the distributed data quite efficiently. And we can say we can combine that topic modeling towards the cloud computing continuum by the dew, edge, and the fog computing paradigms, as well as if we can process the systems intelligently to the multiple layers, right? So first of all, we are going to start with some CDF computing continuum, right? So here we can see a lot of layers are integrated. First thing, we have started with the perception layer. This is called the perception layer, the IOMT device tiers, IOMT. That is called the Internet of Multimedia Things. I have named it as the Internet of Multimedia Things. So this is basically the perception layer. You can say also the sensing layer, where you have already installed the active cameras, the sensor devices, the microphones to capture the real-time data, the real-time informations, right, from the environment. Next, we can transmit this unprocessed data towards the dew computing tier. So here from the actually CDF computing paradigms will start. So in the dew computing tier, we can say now that the dew computing tier is an you can say this is not a mandatory, but this is one of the good paradigms in the computation, in the context of the computation, that can perform the local analytics, such as the filtering, the data pre-processing, the local data processing. Somewhere if the internet is maybe inactive for few seconds or maybe few times, then it can also hold the sessions, right? And when the network is come again on active, then the data will be transmitted to the next layer, that is called the edge computing tier. In the edge computing tier, when you are integrating the edge computing tiers, such as your mobile phones, your laptops, your desktops, so this will perform the low latency, right? And these devices has the less number of storage than the traditional cloud computing systems. So in this layer, we can perform the low latency based computing. We can perform the energy efficient pre-processing. We will have some mechanisms in the context of the multimedia information retrieval in the multimedia information system, audio video compression. We can also check some local processing like the voice detection using the lightweight AI. That means the low resource setting is quite important in the edge computing tiers. Next one, we can say that the real-time filtering, some local filtering, the noise removal to reduce the network bandwidth we can perform in this layer. The next layer that is close to the cloud computing layers, that is called the fog layers. Here, this layer have some several benefits, such as it can perform the localized intelligence, contextual intelligence, some facial emotion, the sentiment recognition from the human beings, the human pictures, from the multimedia portions, and along with that, the personalization with the quality of experience, right? Adaptation it has. Next layer that is the very very mass and quite significant in this to the whole in in the entire continuum, that is called the cloud computing tier. It has the capability of global decision making. It has some certain policies to provide the services to the end users, right? So in this typical cloud computing layers, when the dew computing, edge, and the fog were not introduced, then this has act as the centralized high computing powers and based large scale AI training based models, right? So this model, this dew computing tier, edge, fog, and cloud, they will make one green middleware. That means here from the sustainable computing paradigms will be started. That means when you will achieve the low energy, the energy efficient paradigms, you will find the minimized latency aware systems, you will find the less power dissipated systems at hand. That means it will be focused towards the sustainable schema. That means this is our objective towards the sustainable developments and the sustainable development goals, right? So here the next paradigm, we will have the sustainable monitoring. That means the carbon emissions per processing layers in the environment. We will maintain the socio-environmental policies. We will maintain the economic benefits from the systems, which systems we are going to integrate with the CDEF computing continuum, right? And in the last stage, that means the end user, that is basically the customer. This is the service-oriented architecture, basically. That means which data you are actually storing after processing, after processing and pre-processing, that data will be stored in the cloud. That means based on the subscription, based on some privacy, maintaining the privacy policies, the end users or the customers will take the services from the clouds. So that is the overall benefit. So why we have introduced this DU, Edge, and Fog? Because of listening the cloud's data traffic. If we can easily transmit the unprocessed and the pre-processed data towards the cloud directly, but there the bandwidth allocation, there the energy consumption, the data trafficking will be very, very high. So instead of integrating the cloud computing directly, we will have some certain components, certain devices in the intermediate devices such as the edge, fog, and the dew layers. So next thing, we are going to integrate the topic modeling. What are the features? What are the properties of the topic modeling? The topic modeling is basically nothing but the unsupervised and probabilistic learning strategy. It will discover the hidden themes or the topics in the text, maybe in the documents, or even in the multimedia logs, maybe in the audio the audio logs, maybe in the video logs, like that. So one of the schemas for defining the topic modeling, that is called the latent Dirichlet allocation, that is LDA, and this is based on some of the conditional parameters and the conditional probabilities, where a lot of parameters are there, such as the W is the word, D is the document, and like that all the disciplines. So we are not explaining into the detail, we are not discussing into detail about the equations. Rather, we can say that the LDA method is one of the common methods of topic modeling, and the probability of occurring or extracting words in a document is the weighted combination of topic word probabilities in this particular system. Next one, how we can aggregate the topic modeling with the cloud computing continuum. That means we have some 3 steps, and you can easily identify the potential methods of integrating the topic modeling with the cloud, DU, edge, and fog. That is, first, the cloud trains large topic models using massive data set, of course, because when you are going to store the preprocessed as well as the processed data inside the cloud computing for providing the services to the end users, that means the large topic models. That means you have to extract the large number of features, the large number of topics from the certain documents or from the certain multimedia information profile. Fog and edge performs lightweight inference because they can perform the local computational paradigms, and the DU layer provides the local topic discovery. That may be local topic. That means it has some less amount of storage. So when the network is inactive, then it can also hold the session. And after that, when the network is again on, then it will pass to the next layer. So that means this will provide the continuous flows of the informations which have been accumulated by the sensor devices in the perception layer, right? So this is the overall idea how we can impose, how we can introduce the topic modeling with the cloud, DU, edge, and fog computing. So we can see from here that the topic modeling can be beneficial for the crowdsourcing environment. Crowdsourcing environment means that means it will maintain the divide and conquer policy. That means when and where, in which layer, such as the fog layers, edge layers, or DU layer, how many devices are active, that will easily find out at first, and then that devices will be responsible to compute the local processing, right? So after the local processing, this will be aggregatedly transmit the data towards the cloud. That means the data at first been divided and conquered all the outcomes, and then we used to store the data to the cloud schema. This is the mathematical background of LDA methods. So there is nothing but only few terms, the few components are very, very essential to understand the entire mechanism, the entire analysis, such as already we have seen that in the latent direct analysis methodology, we will have some certain components such as the words and the topics. So words are basically being extracted from the documents, maybe in the NLP context, maybe in the LLM context, everywhere the data are coming. So from that particular overall mechanisms in the time series or the social media data, we must have some directories. The directories we are going to be clustered into different aspects. As already we have seen, the topic modeling is the unsupervised learning. That means the clustering is an important factor, clustering and association, right? So the first term is the clustering. That means we have to extract all the data through the topic modeling concept, and then we will make the directories of the topics and the words. And this data must be multinomial. Multinomial means one logic is there, another logic, that means two or more logics are there within a certain parameter. Suppose I am giving you one example. Suppose you are rolling a dice for 10 times, right? So anyhow the results must be within 1 to 6, 1, 2, 3, 4, 5, and 6. So when the multinomial categories are there, multimodal conditions are there, so on that conditions, you have to prescribe that what are the certain conditions along with the random results. Such as, suppose among the 10 times rolling, we can assume that 4 times 1 will come, 2 times 2 will come, 3 times 3 will come, 1 time 4 will come. So total 10. So that another methods, another conditions have been imposed. So that's why these things are called the multinomial. So what are the conditions in imposed in the topics? That means in the distributed computing perspectives, when you are going to use or utilize the AI methodologies, that variables, the directories which you have already maintained or you have already made, right, already prepared based on the topics, some certain topics or words, that topics must be must be that topic must be significant for your analysis. Suppose you are analyzing one social media information, there are a lot of part of speech like noun, pronoun, adjective, verbs are all that. So adjectives, verbs that are not quite beneficial for the analysis of the features extraction, right? Rather, we can extract the actual keywords, which are the main things. Suppose you are analyzing some healthcare issues, so they are the symptoms, the disorders, some medications. So these things are important. So we are going to extract that type of parameters, not the whole. So that's why we are going to make the directories in an efficient way, where we can also impose some certain conditions to make it. So this is the overall predictive analytics over the ALDA as well as in the topic modeling. Some topic vector has been analyzed because it will process the dimension of the actual clusters. How many directories you have made. So based on that, you are going to make some dimension and the affinity of that particular words that, okay, fine, these keywords must be suitable for that particular clusters like that. Okay. So this is the intelligent data management. Here, one component, one parameter is very, very important. That is called the information gain. The information gain is nothing but our objective is to reduce the entropy, the information entropy on the given data set, maybe in the given data set, maybe in the localized directory, maybe in the localized set of topics. So if we will lessen the entropy of a system, that means we can easily claim that the system's accuracy will be optimum, right? So in terms of the supervised and the unsupervised technique, the classification and clustering, that means the error histogram, the errors which you can achieve, that errors will be less. So if the entropy will decrease, the efficiency of the system, the accuracy system will be gained high. So this is the overall idea of the information gain. So based on that, this topic modeling have been featured. Okay. So now the next topic that we have to compute everything nowadays for the sustainable aspects, right? So nowadays this is the emerging part in any kind of disciplines, maybe in the research, maybe in the societal cares, some in the medical aspects, medical domains, in the society, in the economic perspective, the financial sections, everywhere the sustainability is a big factor. So based on the computational sustainability, the sustainable computing environment, we have the fixed aim that is called that the system must be energy efficient. Energy efficient means we have to try to minimize the energy consumption. So energy consumption minimization means the power dissipation also should be minimum, as well as the latency. Latency is of two terms. First one is the data transmission latency, another one is the information service latency. So this information transmission and the information service, so both latency must be less to make a system efficient. That means within no time you have to achieve the results which actually been provided by the other users or maybe from the other layers in the context of the CDEF computing. This is the theoretical aspects of the sustainable developments. So some issues, that means some motivation, some problem statements are there along with the sustainable developments. So issues are like, see, already we know, we are well familiar with the three terms in the sustainability. That is called the sustainable pillars, right? The sustainable pillars are like that, social aspects, some economic aspects, some environmental aspects, right? So mainly three pillars are there. So in the context of the social issues or maybe in the environmental issues, a lot of challenges we usually find in the recent days in the in the everyday, right? So some hopes of the raw materials for making something, for constructing something. Next one in the energy, that means how much energy we are consuming, that should be less. So this is our important scenarios, maybe for the smart transportation, maybe for the smart societies, smart agriculture. So everywhere the energy is the important factor, otherwise no outcome will become, right? Outcome will be achieved. So the energy should be less. So that is our motto of the analysis in the context of the sustainable development, right? In the context of the environmental challenges, environmental challenges, that means we have some environmental impacts towards the human activities. That means what actually we do usually in our daily life that can hamper somewhere in the environmental impact. So we should be very serious on that. Next one is the demographic challenges. That is the social issue. That means the strong population growth in the developing countries, maybe in the underdeveloping countries. So this is quite challenges. So no resources, that means the resources are limited in the environment. So that's why the sustainable development can be somewhere the critical challenges it will occur. But we have to take care of this. So in the context of the sustainable development, from this diagram, we can visualize everything. That means the employment surplus, these are the necessity of the human beings, right? Along with the healthcare, the smart educations, as well as the quality of life. So everything can be integrated towards the development. The development in terms of the human capital, that means the societal capital, that means economic benefits, as well as physical benefits, that means the social and environmental benefits as well. So it has three pillars: social equity, economic efficiency, and the environmental responsibility. Social equity, just like the living conditions, the equal opportunity towards the communities, diverse communities towards our society, right? Social cohesion, international solidarity, maintenance of the human capital within a specific region or the specific domains or in the specific impacts, right? So next one is the economic efficiency, the economic growth, efficiency and the competitiveness, flexibility and the stability, the production and the consumption of maybe the foods, the materials in the society for the constructing some items. Next one is the employment. So these are the factors, key factors in the economic stability, the economic efficiency in the context of the sustainable development. In the last but not the least, that is called the environmental responsibility, consumption of resources, the energy we are consuming, that is so much. So we have to try to reduce the wastage of the materials, right? So these are the three factors in the sustainable society. So we can depict the sustainable society as the four potential components: ACEP, right? A for action, accountability, affordability, and awareness. C for the conservation, community, culture, and commerce. E for the economics, ecology or the environment, as well as the equity. That means this is the social component. And three P's like people, planet, and profit. So each and every components which parameters are already given there. So basically based on the large component that is called the economic, social, and the environmental sustainable contexts. So in terms, in the domain of the global sustainability, we must have the economic development, ecological development, and the social developments. A lot of factors are there, such as the sustainable economic growths. We have to try to maximize the profits. We have to expand the markets, right? We have to externalize the cost. In the social development area, we have to satisfy the requirements of the human beings in the social life. We have to increase the self-reliance. That means we have to be self-dependable enough to carry out the social development, the social status, right? So in the ecological development, we have the respect, carrying capacity, the conserve and the recycle resources, like that. These are the general indicators in the context of the global sustainability, such as the energy, air quality, land, the smart agricultures, livability, the autonomous vehicles, the transportation, as well as some societal objects, the environmental objects, such as the water, minerals, and the waste. So this is the revolution in the society, that is society 5.0, that has been started with the hunting and gathering, that is our ancestors. Next, the smart agricultural benefits, the agricultural development towards the society. Third revolution was the industrial. Fourth revolution was the information, that is the internet, right? And nowadays, so a lot of behaviors, socio-economic behaviors, socio-environmental behaviors are also integrated with that factors. So that means the new society has been developed, that is called society 5.0. Now we are going to discuss some of the aspects towards the integration phenomena of the topic modeling, as well as the AI, the intelligences with the cloud, dew, edge, and fog continuum, right? So in the traditional management systems, as we have seen in the Internet of Musical Things, as already I have discussed a few components on the Internet of Musical Things in the topics for discussion. Rather, we can start the computational musicology at first. So in the Indian music context, there are two basic rudiments are there. First one is the vocal information. That means the human voices, maybe the male voice, female voice, like that, as well as the instrumental data. That means that the sounds are actually achieved from the musical instruments, right? So when we will gather and we will specify one specific tempo based on the requirement of the composers or maybe the music listeners, based on that the music will be composed. That was the um, a preliminary idea of making music, of producing music, right? So nowadays the system has been changed because everyone not can be organized in the system, because our system, our environment has been changed. The environment is just like the smart environment. That means we are well familiar with the term that is called the internet of things, right? So in this era when the internet of things are gaining momentum, then also the computational musicology, that means the musical context, is also gaining some momentum in terms of the digital music in industries, right? The smart music environments, smart tempo measuring, smart rhythmic behavior. So based on that categories, we have some aspects. So in this category, what we actually do if we will integrate the traditional cloud computing environments with that, as well as the intelligent systems. So what will be the essential components and what will be the steps to measure, to analyze the overall system in terms of the information system efficiency as well as the system efficiency. So at first we are going to be focused on the information system performance metrics towards the disciplines of the music computing systems in IoT. First, the musical sources. Here you can see the musical sources basically giving you the musical components that are really pre-processed and maybe mostly unprocessed. So that data will be gathered. Next, we are going to extract the features and we are going to represent the features using the verification and validation processes. So how many factors are there? That means from the collection to the creation of the musical database, we have to go through some certain steps. The first thing is the music collection. Next one, the framing and windowing. That means we are going to classify into the conceptual behaviors based on some durations, based on some the affinity of the musical notes, like that. Then we can say that yes, the features are extracted. After that, which features we require to compose a certain musical presentation or the performance, we will select the features. We will verify and validate, and after that, we will create the musical database. Right now, the matter is where we are going to store the musical databases. So when we have the cloud computing continuum, then we must have the cloud database where we can store the data. The data will be stored in a particular framework, in a specific schema. That schema is like that, the iMusic database. We have named it as the iMusic. Here, the musical components are going to be stored. Now, in the next step, we are not providing the services to the end user. Rather, we are going to analyze that which data actually we have stored, how we can visualize these materials that which can be beneficial for the future music components as well. So that's why we have taken help of the intelligent systems such as the clustering and the data visualization. So in this process, we are going to build up one system where the unsupervised learning methodologies have been depicted to find out that which features are of which clusters or which groups. So based on that, we are going to categorize and we are going to classify that data into different storage frameworks. Next, we are going to provide some certain frameworks towards the music recommendation based on the rating prediction. So a lot of steps in the rating prediction, a lot of frameworks to design the recommendation systems, like the collaborative filtering. This is very well known framework, the collaborative filtering, by which we can get, or we can imagine, we can assume that where the ratings is missing, where the ratings are missing actually, that ratings can be predicted by the existing ratings provided by the previous listeners or the audiences. So based on that, the rating prediction have been designed by the term that is called the collaborative filtering, and based on that, the data has been categorized into some different clusters. So this will provide the services. That means the cloud database will be responsible to provide the services towards the future listeners. Maybe suppose I am not a music director, but I want to compose one music, so I have to gather some musical components, right? The primary musical components. Based on that, this musical component will be made the aggregated musical features, the musical presentations. So like that. So these services will be provided by the cloud databases. So this is the overall flow of activities what actually taken. So this is the data visualization through Weka data mining tool. Here we have featured into some class and the values. So we had total 40 musical performances based on the Indian classical ragas, and among that we have categorized, we have grouped, actually we have formed groups into two groups, that is the 30 and 10. So one group is performing the Indian classical raga which can be played in the morning session, another one is the night session. So based on that we have categorized. So just only the example we have taken here as the performance matrix, right? So this is the overall rating prediction. So this is mainly performed by the collaborative filtering mechanisms. These ratings were missing in the database. So based on that user and item components, this rating have been predicted by the previously defined or the previously indicated values by the customers or the music listeners here. Okay. So these are some comparative analysis. Here, the overall idea of Internet of Musical Things. That means this is the integrated phenomena of the conventional IoT process with the computational musicology. So why these extended paradigms are important? Because this integration phenomena of the musical components with the IoT, that will have the certain significances and the advantages, such as you can perform the remote performances. That means you can achieve the remote performance data, right? So suppose every musicians are connected with a shared network. Based on that network, they are performing from their home or from their diverse locations, and you are achieving all the integrated data at a time from your home. So this is the remote performance framework. Next one is the smart rhythmic behavior. We can change the potential rhythmic behaviors of the smart musical instruments which are appended with the systems. Auto tuning of the instruments, so we can easily change the tunes of the smart instruments as well as the altruistic music information fusion. That means we are also be able to aggregate the music information fusion systems. So this field means the Internet of Musical Things is positioned at the confluence of the conventional music technology. That means this is called the computational musicology. Next, the conventional Internet of Things. It will provide the services toward the human-computer interactions that should be beneficial. And we are also integrating the machine intelligences for applying in the smart musical contexts. This is the overall architecture. This architecture is just similar to the traditional cloud computing continuum in the context of the CDEF computing. We have taken here the 4 layers. First one is the physical layer, that is called the perception layer. So perception layer consists of the musical sources of the environment, and we have placed the sensor devices. The sensor devices will accumulate all the unprocessed data from the music sources, and then it will transmit to the edge computing layers. So all the local analytics, the local analytics such as the responsive and the interactive computing paradigms, this will be performed in the edge layer, and after successful processing, that data will be transmitted to the cloud layer for the storage and providing services to the end users. So end users means they have the certain APIs, they have some certain login password mechanism. So based on that, they have the subscription. So based on that, they can subscribe and they can easily access the cloud data which have been actually stored based on their requirements, right? So this is the overall flow of activities that is designed to make the readers understand how the data is flowing and what are the components inside to perform these overall mechanisms to design these certain systems. Right. Next one, in this particular paradigm, we have discuss the performance metrics in the system component based on the system component. The system components are like that. First one is the latency, second one is the energy consumption, and third one is the power dissipation. So these are the primary components for making a system sustainable. If you can verify that yes, your system is trying to minimize or gradually minimizing the latency, it is gradually lessening the energy consumption, that means you are in the correct way to analyze the whole systems based on that. So time analysis means the latency at the delay of the system. Time analysis means how much time it needed for the data processing, data transportation, and providing the services to the customers. So that is the time analysis. Based on that, you can say the latency also. This is the energy consumption. This is the formula of energy consumption in the system based on the musical data packets, the system, how much energy it has consumed, that has been basically depicted here. This is the comparative analysis of the power consumption in the three different, the drivers IoT fields. First thing is that when we are just only using the cloud, not the edge devices, rather we are transmitting the unprocessed data directly in the cloud. So the data traffic as well as the power consumption must be high. So we have depicted as high. So that one that we have made one system that we have taken the edges, but we are not performing anything in the edge, but only to transmit the data towards the edge. So that's why the data traffic power consumption is lesser than the traditional cloud computing environment. And third one is our proposed mechanism where the edge devices are performing the local computing as well as the cloud are only for the storage and to provide the services to the end users. This is the comparison of the service time. You can say the service latency as well within the two parameters. So one component is where we have not used any kind of middle layers. Middle layers means the edge, fog, or the dual layers, and another layer that is called another paradigm that is called the conventional cloud computing systems. Okay, this is the music information fusion. Information fusion means which data we are actually gathered from the physical layers or maybe from the environment through the sensor devices. That data, after local processing, we are going to aggregate in the layer that is called the IoT analyzing layer. Here, a lot of paradigms, a lot of devices you can use, a lot of platforms are there available. Maybe you are using the Amazon AWS, Microsoft Azure, everything. But we have used the MATLAB framework that is called the ThinkSpeak. Okay, so for the IoT analyzer, that means how much time does it need, or what are the components are actually benefiting, what are the frequency values in the context of the music, that the frequency and the pitch are the essential factors to identify the certain components in the musical musical elements, right? So that's why we have taken the ThinkSpeak paradigm to design the music information fusion system. You can also easily make this paradigm beneficial for the multimedia information fusion systems as well, where the natural language processing, the audio files, sound, text, image processing symbols. So everything you can do from your own based on the requirement, right? So this is the overall flow of activities of that proposed system. This is the information entropy. Information entropy basically providing the system's uncertainty behaviors, right? So we have found that in this particular case, the information entropy were quite higher, and rest of the cases were found stable. So that's why we have taken this information entropy to produce the system efficient. Okay. This is the efficiency chart based on the data storage in the cloud after computing. These are the normalized rate of efficiency. So here the efficiency is so less, but this is gradually been increasing. So this can be standard. If anything needed to introduce with that for measuring the efficiency more higher, That's why we have taken the help of the topic modeling. Topic modeling means we are extracting the latent features, the hidden features as well. If the hidden features you are going to integrate, maybe sometimes the hidden features also um, given you the chances to achieve the higher, the optimum results in some certain disciplines, right? So this is the overall comparative analysis, just like the three paradigms we have taken already. We have accumulative number of data packets. So that means our system may be proficient, we claim. Okay. This is the crowdsourcing framework. Already I have told you that when one particular task will be there, that task will be distributed based on the efficiencies of the um, devices. That means which device can do what based on their performances, based on their efficiency. We are going to divide the task for the better and the optimum outcomes. Okay, so after taking all the resources and after accumulating all the efficient results, we will again amalgamate to the data server. This is the cloud data server, and based on from that data server, we are going to provide the services to the end users or the requester. That means they can request also for providing to achieve the services from the centralized data center, that is cloud. Okay, this is the Dew computing framework. Just like the same, we have introduced the Dew computing layer here only for the local analytics, the basic analytics such as the filtering optimization, the data buffering and the caching and holding the sessions. Already I discussed with you that for Dew is very, very beneficial and significant in the context of IoT or maybe in the CDEF computing performances, that it can hold some sessions in their local storage. The local storage is very, very small in size, but although when the internet may be inactive for maybe a few seconds or maybe for a few times, then it can hold the session, and when the net is again active, then it directly transmit to the next layer the data. So this is one beneficial and the key factors in the newer cloud computing continuum process. So again, the service time analysis, the service time, the service latency of the musical data packets we have given. So when we have introduced the Dew with the particular paradigm, right? The energy dissipation. This is the overall comparative analysis among the, between the two paradigms. First one is the conventional cloud paradigm, that is denoted by this. And the second one is the Dew-induced, the crowdsourcing paradigm, where we have introduced Dew for making the system more efficient and more scalable. This is the comparative results. This will continue. Next one is the terms that is called the big data. Already we know we had started with the three disciplines. That means the value, volume, and velocity, right? Big data, three V's. Nowadays, the big data not only restricted within the 10 V's, rather it has been extended up to 15 V's. Okay, so why these big data 10 V's are important? Because we are going to extract the topic features, right? So topic features are like that. Suppose I am taking one example here, the V1 to V4. That means only the 4V component, only 4 features we have identified, and based on that, we have mapped that how much affinity of each and every cells has, right? So when only one data is going to be introduced, that means the maybe the document, right? When you are giving one document as the input, the system will define that how in the context, in which context that variables and that keywords will be essential. So this will define the clusters as well as the recommended framework, that yes, this data is this and it has the affinity within that particular matrix is this. So like that, you can frame one context by which you can achieve some dynamics index allocation of the data. That means this will be very, very helpful for the tagging, the data tagging, information tagging, that one. Next one is the hybrid matrix factorization. Just like this is the similar concept of collaborative filtering, the collaborative filtering and the context-aware decision making. These are the domains, the criteria for making the recommender systems. Maybe the multimedia recommender system, maybe some people, maybe some latent features, all the recommender systems. See, this hybrid matrix factorization is also an important factor to provide the recommender systems. This is already induced with the topic modeling. What actually hybrid matrix factorization do? The matrix factorization will be based on some multimedia informations, multiple data sources. They will collect the data. Based on that, they will create one matrix. But when the topic modeling will be integrated with that particular matrix factorization methods, that will define the more scalable and more efficient paradigm for providing or for analyzing or for predicting the actual or the optimum ratings of a specific product, right? Because the topic modeling is already predicting some of the latent features, the hidden features from one database, right? So you can also we can also integrate, we can also associate these paradigms with the CDF architectures in the different layers based on their requirement, based on their formalities and the analytics principles. This is the overall mathematical background. We have some three metrics: the document word matrix, metadata matrix, and the sensor matrix. This metadata matrix and the IoT matrix, these components were not there in the traditional matrix method because there was only user and item based mechanism. So we have embedded the additional keywords try to make the system more efficient and to predict the more optimum results, more optimum ratings towards a particular item by the users based on their sentiment also. So based on that sentiment also, that's the sentimental behavior, the personalized recommendation systems can also be integrated with that particular systems. Okay. So this is the mapping paradigm of HMF, hybrid matrix factorization, towards the CDEF. That can have, already we have the 5 layers, that is the perception layer, the sensor devices, collected raw signal, construct small local matrix. Local matrix means based on that the user and item components. Next one, dual layer, is the local analyzing tier. See, this layer is also associated with the perception layer here because we have taken this dual layer only for the local analyzer. They will create only the zero crossing values or maybe the negative ratings already been provided by the systems. So this should be discarded from the system directly. Okay. Next one is the edge computing tier that will provide the gateways and the mobile devices, aggregate the due information, runs the partial factorization. Partial factorization means each and every device will be responsible to compute a particular matrix generation results, as well as the embedded objects with that. The embedded objects will be found in the fog layers, maybe also in the regional servers, because edge level factorization, that means the hybrid factorization, will be depicted in the fog layers. And last but not the least, that is the cloud layer, where the centralized AI, because here you can see only the depicted paradigms where the hybrid matrix factorization methods has already been performed, and based on that the results have been provided in an optimum way. That is our motto. So based on that hybrid matrix factorization, we have designed one particular environment, because this paradigm is not well familiar in the context of the computing domains in the computer science or maybe in the IT. Rather, only 2 or 3 contributions are available in the internet or in the market. First one was introduced in the year 2011, and after that we have introduced in the year 2023. So this paradigm is the orange computing. Orange computing, they have proposed, the scientists have proposed this orange computing, this term, due to analyze these 3 components. The first one is the health, next one is the happiness, another one is the physio-psychological orders. I mean the physio-psychological behaviors of the human beings. That means these all the analysis were based on the behavioral settings. Behavioral settings, that means the sentiments, emotion, the human behaviors. These parameters they are going to introduce. So based on that, we have made one architecture where the orange computing tier is also there. So here we have taken some of the the hybrid matrix factorization component, that means based on some latent features. Latent features means the behavioral features of the human beings. Okay, so based on that, we have taken additionally as well as the metrics of the users and items. So based on that, we have found the ratings are quite good. So in the most cases they were good. We cannot claim that our results is the optimum, no, because a lot of hidden features are already there which we have not granted, we have not examined. So that's why our result is better than the traditional systems of the traditional matrix factorization mechanism. So when we have introduced the topic modeling based uh, the HMF, hybrid matrix factorization model, then the result would be better. So we can claim that result was really better than the traditional mechanisms. And also we have tested this result with the collaborative filtering also. So on that discipline also, we have found the better results in terms of some certain musical data points. Okay. So now we are going to discuss some additional case studies in the context of the Internet of Sounds and the Internet of Behaviors. That means the sound and behavior will be integrated together to be beneficial for the societal aspects. Okay, for providing the sustainable aspects. So the problem statements, or maybe you can say the motivations. What are the motivations there? The motivations are like that. First challenge we have to face that the information silos. What is the information silos? Because till now a lot of paradigms have been depicted, but there is no integrated phenomena is available where the acoustic signals and the behavioral patterns of the human beings they have found coherently. That means this fusion model we have not depicted till now. Another thing, when you are going to introduce the high settings AI features, that means the heavy AI models, then obviously the system will consume the high energy as well as some high resource footprints. So that's why our intention should be the system must be low resource settings, as well as the system should be energy efficient, right? So real-time context awareness for sustainability in terms of the human comforts, the people's safety, as well as the carbon emissions remains limited till now. Lack of standardized framework of sound behavior fusion in the IoT iOS, because there is no standardized framework. Nobody has appended so that this paradigm is very very good and optimum to provide you the best results, optimum results. No, there is no certain framework, but we have been trying from the past and still now we have been trying. Yeah. So possible concepts of the solution, that means we have to make the information system or the multimedia information fusion systems where the Internet of Sounds with the human behaviors, that means the behavioral sensings, will be integrated. Next one is the multimodal features, because this has the different features. This will make the spatio-temporal features like the convolutional or the recurrent neural networks, right? So this will give you the better idea of the transformer fusion. Next, the feedback loop that nudges the behaviors and actuate building urban system. That means the feedback loop means trial and error. That means the reinforcement learning can also be the important factor within that proposed solution. So proposed fusion pipeline may be like that: the acoustic sensing we will accumulate at first, then we have to introduce and we have to extract the behavioral capturing through maybe the topic modeling, maybe the SVD. A lot of methods are there already in the topic modeling. So one of the methods can be vital for extracting the behavioral components of the human emotions. Next, we have to create the multimodal data fusion. That means the behavioral factors will also be available, as well as the acoustic sensing factors will also be there. Based on that, the fusion paradigms will be depicted. Next one, the learning and inference. Learning means how much knowledge representations we have, how much features we have taken, what are the features, whether the features are actually significant or not for the system defined system, right? So that one. Next one is the sustainable decision. We have to take in the three-way sustainable decisions. Maybe this should be the economic, as well as the social, as well as the environmental sustainable. Next one is the actuation and feedback. The reference architectures like that, like CDF computing, first one is the sensing, MEMS, that means the micro electromechanical sensor devices, the mics. Okay. The next one is the edge devices, the lightweight. That means the low resource, lightweight noise filtering on device keyboard in the event detection. That means how much we can suppress the complex features, the complex components from the system. That will be really good to identify and to examine actually that how the system is behaving. And after that, when we will deploy it in the real-time applications, that will be really good when the systems will be like that. Next one is the cloud. This will provide you the federated learning architecture. That means the local analytics and the global analytics will be performed together. Next one is the policy optimization for sustainability key performance indicators, right? The last one is the governance. Governance is this data which you are which we are going to accumulate, which we are going to analyze for the system, that should be privacy preserved, as well as should be ethical sounds to be captured from the environment. This is the overall proposed architecture outline, although we have not performed yet till all the things, but this stipulated outcomes in these diagrams. These are the behavioral schema. In the behavioral schema, we have the 5 behavioral components as well. First one is the data sources. Next one is the data processing and storage. Third one is the behavioral models. Fourth one is the actionable insights such as the recommendation and decisions. Already we have discussed a set of specific models. Last but not the least, that is the application areas. The application for the societies, application for the environment, application for the economic benefits of the society, such as the healthcare, smart cities, smart markets, workplace. That means the smart universities, like that, and the sustainable context. First one of the case studies in the proposed case studies, that is called the proposed case studies, the net zero smart campus. Already researchers have depicted one augmented solution, the virtual solution for the net zero smart campus, and they are trying to reduce the heating, ventilation, and the air conditioning within the performance system. That energy should be consumed less. They are going to minimize greater than 10% without comfort loss. That means the students and teachers and the other staff members cannot suffer within the campus if this is the university campus, and minimum 10% and maximum how much it can be. That means minimum 10%. That is the threshold they are trying to avoid without comfort loss. So based on that, they have framed a set of certain simulation results also. This can be effective, but a lot of potential challenges are there. They are going to use the methodologies like that, the CDF continuum concome, as well as the carbon emission process, the carbon emission footprints. This also they are taking the methods of the reinforcement learning, but the results are not optimum till now. As we can know that the result should not be optimum because there is no end of doing good, right? And the noise complaint. Noise means the internet of sounds. That's why this paradigm I have mentioned there. And the noise complaint should be reduced by 22% within the smart campus. This is one proposed case study. Next proposed case study is the urban mobility for the quiet corridors. Quiet corridors means where the residences are there. In the residence, when the people, the trespassers are going to pedestrians are usually walk and usually runs on that particular sites. The noises and the environmental effects, their effects should not be matched, should not be put with that particular events, right? So based on that, the urban mobility and the quiet corridors they are using. So these are some results. They have taken some simulation results. They have provided it, although we have a lot of scopes to redefine these objectives, to redefine the mechanisms by which we can make the better outcomes from the systems in terms of the information performance metrics, in terms of the system performance metrics as well. Another case study is the cognitive music therapy. A lot of music therapies are there already, we have heard, but till now no therapy, because here the sentiment, human behaviors, physio-psychological disorder of the patients all are involved, right? So that's why this cognitive music therapy is a very significant for the smart healthcare in the nowadays, right? So these things will be started with the patients who will be equipped with the smart instruments. Next, the devices will capture the sound and motion. The edge devices, that means the potential disruptive IoT paradigms, will extract the emotions and behaviors of the system. That means the medical questions, the disorder, where from the disorders are coming, that will be identified. Next thing, aggregate all the patterns, and then they will impose the actual therapy, the recommended therapy for that particular patients, right? So this is one of the emerging and proposed case studies in the evolution of the healthcare, potential healthcare. Next one is the intelligent music generation and reconstruction. Although the music industries have already have the affinity to compose the music in the digital music and the intelligent music environments, but a lot of methods also are involved, a lot of components are also involved which are not traced till the date. That means the behavioral context, that means the sentiment you cannot categorize in a very specific way, because the human sentiment, the human emotions, these things are not always fixed, right? So this can be changed with the time. So that's why you cannot predict the specific and the stipulated mechanism for providing the intelligent music generation and the reconstruction perspective. Maybe your result may be good, maybe better, maybe the best in some certain circumstances, but we cannot claim that the results are optimum, right? So, in the context of the application domain of the future perspective of the Internet of Sounds as well as Internet of Behaviors, the smart building and campuses, the smart campuses, Industry 4.0, maybe nowadays this has been extended towards the Industry 5.0, maybe. In the vehicular things mean the smart transportation systems, right? Next one, the environmental stewardship, where the bioacoustics, that means the sounds of the animals, sounds of the human beings. So everything will be captured, and based on that, the sound will be pattern matching. That means their emotions, their sentiment can also easily be understandable towards the human beings as well as to the intelligent systems. These are some of the emerging trends. These are some of the emerging trends. That means this method, the topic modeling inspired, AI driven, sustainable CDF cloud computing, CDF computing continuum. In this case, the federated topic modeling, as we have discussed a few things on that federated learning methodologies, and this to be applicable for the privacy preserved cyber physical systems. Next one is the large language models. If we gonna integrate the topic models to make one system as the interpretable AI, right? That means we must have all the transparencies with the data, maybe in the natural language processing, maybe in the large language models, maybe in the virtual assistances, everywhere should not be any black boxes. That means every results must be transparent, every outcomes must be achievable. Next one is the quantum AI for edge devices. Quantum AI already there in the Microsoft Azure or in the Google Cloud, everywhere, one service oriented architecture has already placed. That is called the MLAAS. That is called the machine learning as a service. That means if you are using the public cloud platform for computing or for analyzing some disciplines of the cloud data in the context of the public cloud environment, then you will have a lot of good result. That means they are providing a very efficient platforms. Okay, but when the quantum computing nowadays are very really emerging topic, so based on that quantum AI, we can say although I don't have a lot of ideas on the quantum AI, but I can say some of the essential components and the quantum AI, such as the superposition and entanglement, right? Maybe you will agree with me. There's two terms. The superposition means when you are going to convert the digital data into the quantum states, that means you have to make the system's reflection. That means each and every layer, each and every devices are capturing the quantum states at a time. And after that, they are making the bridges. That means the connectivity between the two quantum states, or maybe two or more quantum states. That means they can easily transmit the data. They can easily interact within them. So based on that services, the IBM Quantum are trying to develop one service that is called the QMLAS. That means they are going to introduce one feature that is called the quantum machine learning as a service. Although in the private cloud environment, we can easily deploy who are the experts in the in the quantum technology. They can suggest also that what must be the components in the public private cloud domains, and based on that, the cloud, in the private cloud environment, sorry, in the public cloud environment also, there must be some dedicated service related architectures in the context of the software as a service. Okay. And last but not the least, that is called the integration with 6G networks with the ultra low latency. So already we have defined that the 6G is ultra low, and already we have heard that the 6G is coming with very intelligently. That means the intelligent aware system protocol. That means they will provide the service to the end users very efficiently and intelligently. So that's why the integration of topic modeling for the feature extraction in the low resource environment, where the latency is also low, maybe ultra low. So on that perspective, we can compute easily the energy consumption and the power dissipation models to identify that whether and how much the system will be more efficient towards the next generation of the internetworks. Some research questions after discussing all that topics, all that components which we have already been discussing today. The first question is how to distribute topic models efficiently across all 4 layers in cloud, dew, edge, and fog. That means we have to furnish all the ideas what we have been discussing nowadays, and we will discuss in the future also. That means our distribution must be equivalent, and distribution should be in a very good way, as if the system will provide us the result in optimum standards. Next one, how to balance accuracy, privacy, and sustainability at a time. That means these are the research challenges, not the research question. I can say the potential research challenges, the research questions. How to combine topic models with multimodal data, the text, images, and sound. The topic model means here the behavior patterns are also there. That means the latent features are also to be associated with the paradigm. So these are the challenges after the potential discussions. So this is the last topic, that is called the observations. You can say the conclusions as well. That means the topic modeling is a bridge between unprocessed information and insights. Of course, that means the information and insights, that is called the latent or the hidden features. Next one is the cloud dew edge for computing enables layered AI intelligence. Of course, when we are going to provide the intelligences each and every layers and each and every devices in the associated components. So that means we are providing. So providing the services. That means our actual aim to get to achieve the optimum services, efficient services, where the energy will be less, the power consumption will be less, the latency will be less, and the entropy, the information and the system, both entropy should be less, and then only we can gain the information gain as well as the system gain also be there. Last but not the least, I must claim that all the faculty members who are involved in the researches or in the developments, they can play the pivotal knocks in advancing these domains which already we have discussed today. So here I am going to conclude my presentation. If you have any question, you have any discussion, the topic for discussion, then you please feel free to ask me. I shall be very happy to answer. Thank you.
Any question from participants? Any question from participant? You can ask directly or you can write the question on the chat box. Any questions? Okay, thank you, sir. Thank you.
madam. Yeah.
Thank you for such an informative session on CloudView Edge for computing. So,
Mamita madam,
yes, can
please
I
ask sir. Please
Huh.
ask sir to.
Switch on the video.
Yes, yes.
Okay.
Sir, please switch on the video.
Yes,
To
yes,
take
yes.
the photograph.
Sure. Yeah.
Thank you, sir.
Thank you, sir. Thank you.
Prashanjit sir, can I conclude the session?
Yes, ma'am.
So we now conclude today's FDP session, and I sincerely thanks our speaker for the valuable insights shared and all the participants for your active involvement. Thank you so much.
Thank you very much to all the respected participants. Hope to meet you
Prashanjit sir,
soon
please
in the another
mention
program.
tomorrow's timing. Yes, we are informing in the WhatsApp and we will give the details about the test session also. Tomorrow there will be a test and we are taking the attendance from the Zoom meeting. If you have attended the Zoom meeting and we have given the attendance.
So I am ending this session for today. Good night, everyone.
Yeah, good night. Good night to everyone. Thank you.
Good night.
Thank you, sir.
Yeah, bye.
We are taking the attendance from the Zoom meeting directly. We are taking the feedback